today we're talking about areas of similar figures, and we have a theorem with this one. So theorem 11.1 is the areas of similar polygons, and it states that if two polygons are similar, then their areas are proportional to the square of the scale factor between them. So what that means is if you know the area of each and maybe one of these two pieces, you could find the missing piece, or let's say we know the scale factor in one area, we could find the other area. But basically all you do for scale factor is it's like, just using my line paper, like this could be 2 where this is 3. So maybe you would say like 3 over 2 squared equals, and maybe we knew one of the areas. So that's how you'd plug it in. So again, area over area equals scale factor squared. Okay, so for our example here, we have two rectangles, so they are similar polygons because they're the same shape, they're just different sizes. We know the length is 8 centimeters of the larger rectangle and it's 5 centimeters of the smaller. And we know that this area is 32. Now we could just say, okay, well 8 times what is 32 and get 4 and make, do it that way. There's a lot of ways you can think through this, but we're just gonna use this formula right here. So the area of the first, we'll just say 32, over area of the second, well we don't know that, that's what we're looking for, equals the length of the first over the length of the second squared. So we're gonna square this first, and to square a fraction, you can just square it separately. So 32 over x equals 8 squared is 64, 5 squared is 25. Okay, a couple ways to think about this. That's half of that answer if you want to just look at it, but we know to solve a proportion we can do cross multiplication. So 64x equals 32 times 25, which is 800. And then we'll divide by 64. And 12.5 is our answer, which again was half of that 25 if you want to just look at it. So our area that we were missing, the area of this right here, is 12.5 centimeters squared. And again, make sure you're paying attention to your units, even if we're just finding it for similar polygons. Okay, and for our last example, we're just going to work backwards. We're asked to find the scale factor in x. So we're going to find the scale factor from the first to the second. We're just going to read left to right, but if it tells you specifically, like by color or by, if it labels it, just do in the order it says. But we're going to go left to right since that's the way we read. So we're going to fill it in. So area is 50 over 72 equals x over 6 squared. Now, we could square this, or we could take the square root. It's really your choice here. So what I will probably do is I might reduce this first actually, because neither of these are perfect, but I'm thinking that 50, if I divide that by 2, is 25. That's a perfect square. So maybe just reducing. So let's see, that would be 25 over, and let's see what's half of 72. So 72 divided by 2 should be 36. Yep. And so that's gonna be a lot easier to do the square root of. So I'm gonna take the square root. So I have x over 6 equals, okay, square root of 25 is 5, square root of 36 is 6. So this is my scale factor because we're asked to find both. So scale factor is 5 over 6. That's one answer. Now we got to find x. Well, if 5 over 6 equals x over 6, 6x equals 30. The 6's cancel. Again, you can tell just by looking, but I'm showing you the math. You would get that x equals 5, and it will be 5 inches. So again, when we can write the units, let's go ahead and do that. So that is how you work backwards to find scale factor and x.